Good morning. I'm Pablo. I work also on the OData team. And what I wanted to do in this part of the presentation was to talk about V3. My goal was to do a pretty detailed drill down on most of the features that we worked through in this round of the protocol. And in particular, I'm going to focus on the protocol rather than on the particular implementations. That said, feel free to interrupt me every time you have something there. I know a number of you guys have been working on implementations out there already. So, thoughts, complaints, everything is fair game. So I'll cover most of it. I'll leave just two topics out just because we'll have specific drill down presentations on that later. But if you want to also ask questions about that, you're welcome to. And I'll either take them on the spot or we'll push them to the right sessions. So thinking about V3, as Mike said a minute ago, the way we think about V3 is we've been baking on this for a while, and we've seen a lot of people use OData for a whole bunch of things. And over this time, we've learned what things have been interesting decisions that have caused a lot of complexity outside because the right thing wasn't there inside. So what we wanted to do in V3 is really take a hard look at what things would really make a difference, such as if we had them, a lot of people would have an easier time working with OData. And second, for all the things that we couldn't do, either because there is only a finite amount of time we can spend on this, or also because it was too narrow for everybody to really use because it was for a specific kind of problems, how could we enable folks to add functionality to OData without causing servers and clients to choke, but having clients that know about this, or servers that know about these things to take advantage of it. So extensibility has been an important topic throughout the release. So I'll talk about functionality that we built into the protocol first. Then I'll talk a little bit about efficiency. And finally, I'll briefly touch on extensibility, frame it a little bit. And then the next two sessions will drill a lot more into that. So functionality, we made changes in functionality kind of across the board. If you look at OData overall, there are aspects of functionality, like aspects of the protocol in general. You can think of them as either it's a modeling thing, as in what kinds of things you can describe and where they go, or it's an interaction thing, like what is the interaction model between clients and servers, or it's a query thing in the sense that it changes the way you can formulate questions to the system. So examples, like the first example of this is collections. This is one of these little things that they don't seem to be a big deal until you see a lot of apps out there doing ugly things to work around this problem. So the basic problem is very simple. You have a contact or some entity like that, and the thing has simple properties like name, last name, and then you go emails. And sometimes you have one and it looks good. Sometimes you have many. And what do you do with that? If you don't have something like this, then you can say, well, I'll just make it a string, and then I'll do a comma-separated list. Really, is it a comma separated? How about semicolon separated? How about space? Like now we all have to agree on this. And then how do you modify it? How do you ask a question? Like you can't use equals anymore. If it is like, there is this sense of, well, this is so simple. Let's keep this type system as small as possible. Except the moment you do, what happens with these things is complexity shifts to the user of the API. So a lot of people worked around this by saying, well, no worries, I'll just separate it. You already have relationships and links, so I'm going to take the email out and put it in a link. But that makes you do weird things. Now, emails don't come by default in entities because they are kind of related, so you have to follow a link or expand it. And also, like, unless the email is the key of the entity, you have to kind of have a key because this goes into a different collection, and how do you address it? So this is really taxing everybody. So we said, no, actually, this is worth the hit. We're going to introduce a collection concept that allows people to model entities that have attributes that effectively are not in first normal form, which meant we had to change our query algebra, and I'll get to that in a second. But for people that don't care about any of that, the practical implications is you can just have a collection of properties. So most people will never think about all these and say, okay, that makes sense. Why didn't you have that before? The one thing we did is we kind of went a full way around this. We first said we're going to invent this new concept, and we debated the name a lot. It was a bug or a multi-set, and then we ended up calling it multi-valued property for a while. But the one thing we noticed at the end is actually top-level collections and nested collections like this look a lot alike. There are some differences, but look enough alike that we thought, actually, let's not invent another concept. Let's do the due diligence to make these things line up, and let's say there's just collections. So now for anything, primitive, entity, complex type, whatever, you can talk about a singleton instance of it or a collection of it. And it's very uniform throughout the system. The formats are consistent. The way you interact with them are consistent. So for the most part, it's pretty much on point. The primary difference that you can observe if you pick kind of deep enough is collections of entities can be very large, and the whole system is designed to handle them even if they are arbitrarily large. So there's paging and queries and all that. Collections are considered a single value. So collections is not a thing you can add one and remove one, or you can't do deltas or filter them or so on. So the collection, it's expected to be small enough that you would retrieve it with the whole entity, just like say the name or any other attribute like that, and put it back with the whole entity. Syntactically, in the model, there is when you declare a property that is of a collection type, which is a collection of something, this allowed us to keep all the rest of the type names as they are, which means either built-in types or your own custom types can just go inside parentheses, and it causes less churn there. In the atom representation, collections look like this. It's just a wrapper and a series of elements. In this case, it's just strings because it's the emails from the previous example. And the current JSON wrap has the content itself is an array, and it has a little marker that says what the type is. And I'll talk about making this a little cleaner later when I talk about JSON more. So the other challenge with this thing, and I'll generalize it to other aspects as well, but with that is, so once you have either the comma separated trick or a real collection for emails, then how do you ask questions? You can't use equals anymore. I guess you can use substring, but that's really clunky. So how do you allow people to ask questions about this? That's an example of a broader class of questions you may want to ask, which is I have people and events, or movie and actors, or all these things where you want to formulate questions about these two items that are related, but the cardinality makes that you can't really ask a question, like you can't say where the actor in this movie is called Fu, because you have to say which actor, or where the where the email is blah, because you have to say which email. So I guess a way of formulating this class of questions is to say, in the previous schema that I showed a minute ago, if you wanted to ask, give me all the contacts with email address a@b.com, how would you ask that question? You can be tempted to say that, and that works if emails was just a string. But if emails is a collection, this actually, what is the semantics of equal there? Is it any of them? Is it some of them, all of them, sometimes, the whole collection? So it doesn't really work. So what we did is we introduced one extra trick into the URL syntax. Is this any operator. So any is a quantifier that allows you to kind of introduce another predicate that applies to the collection. So in this case, what this reads, give me any contacts that has any of its emails satisfy the predicate inside the any clause. And the any clause says, well, where E is a@b.com. Where E is is a way of binding the variable, giving a name to the iteration for that particular collection. We debated this syntax a lot. We said, well, first we experimented with a function syntax. So it was just like a regular function called any. The problem with that is that took away a lot of freedom for how to manufacture the rest of the syntax. We also tried not to have the E column at the beginning, so no variable binding at the beginning. The problem with that is makes it very hard to do correlated things where there's more than one pivot you're trying to coordinate. So after a long debate, we kind of settled on this. And this actually works on collections, like in this case where emails is a collection property, but also works on anything that represents a one-to-many or actually a too-many relationship. It doesn't matter the source cardinality. Like for example, assuming that contacts have an events collection, that is the events these contacts are attending, you could say, well, what are the contacts that are attending one or more events this year? So you can ask that as, well, in this case, events is a navigation property. So it takes you to another entity, not to a list of primitives. And it says, well, of the events, give me anything such as E. And note that in this case, I can address deep into E. That's E/date is a property of the event object. So the iteration variable now is not a primitive, it's an object. And the whole thing continues to work. You can drill inside the object. And in this case, it says, well, where the year is this year. This also composes well if you want to kind of nest it inside. So for example, if you want to say, give me all the contacts that attended events tagged work. So you can say that by saying, well, give me all the contacts for which all of its events, this is a different form of quantifier. It requires that all of them satisfy the predicate. And then event has a tags property, which happens to be a collection of strings. So then I'm doing another any of the tags is work. So the syntax kind of naturally nests. I mean, it can get very fancy very quickly. Well, I'm assuming most people won't write this sort of stuff. But the infrastructure is very sound. It allows you to ask simple questions, but it stretches very far as you need to get fancier and fancier in the way you ask questions. It also gives us this lambda-ish construct that is handy. It's probably a tool we'll use in the future if we need to do something else along these lines. We'll probably not need to invent a lot more in the syntax department here. So the other modeling construct that we've had for a while, but
can I ask a question?
Yes.
What is that extra word filter doing in this? Why do I need filter equals? Why isn't it assumption that it's a filter?
So the question is, why do we have the filter query string option there?
Yes.
Well, so I guess there's two aspects to it. So one is, we have to have some query string there. We're after the question mark, so the syntax has us having some value equals some name, so we can look it up. We could have just this as the name of the query string option and no value, but that would be very unusual, from the style perspective. The other thing is, one thing we do in OData kind of across the board is we have a set of well-known $prefixed options, which ensures that OData will never pave over people's query string options. So we take the ugly $sign so you guys get the nicer query string options.
We had that discussion when you were there.
Yeah. Yes, we had. So inheritance, yes, sorry.
So can you go back to the
Yep.
example? So looking at these filter expressions, I'm struck by how similar, or they remind me of OCL. Is anybody on the team familiar with OCL?
I'm not.
Object constraint language?
So the question is, I have someone saying, repeat the question, please. So the question is, how related is this to OCL? I'm not familiar with OCL. I don't know, maybe some of the folks, nobody?
Anybody in the room ever heard of object constraint language? You see like it's sort of covering the same area?
Looks similar.
Well, yeah, there's a surface similarity, so this is just sort of an FYI, I guess. Maybe do some web searches and see if there's some overlap and you can steal some ideas.
Yeah, I'll take a look, definitely. Yeah, and a lot of this is borrowed from places. Like we kind of took inspiration from many places to come up with this. But I wasn't familiar with it. I'll take a look. Any more questions on collections? So inheritance, I would say for inheritance is an area where we've had inheritance support for a while. But we never rounded up the feature well. And I was surprised how much people use this. Part of the reason why we never really rounded it up is because we weren't sure people would do a lot of this. Like we thought, well, web APIs, these tend to be very simple things. Why would you go as far as modeling heavy inheritance and really push the feature? Well, it turns out a ton of models have inheritance in them. I'm surprised by the ratio of models that use inheritance extensively in their models. So the problem we had with inheritance is, so let's say you have a setup like this. So you have the same contact object we had before, and then we have a subtype of contact called employee, and there is some property of employee that is specific to it, in this case, the manager. So if you say, give me all employees managed by Andy, so how do you formulate that question again? You could write something like this, and says, well, traverse the manager property and then get the first name and see if he's called Andy. The problem is that we are typed people. I don't, not all of us. I am. So manager, I mean, the iteration variable from the static perspective, like at compile time, so to speak, contacts is a collection of contacts is a collection of contacts, not of managers or employees rather. So they don't have a manager property. So if you do this as a if you think about this as a dynamic language, you can say, yeah, no problem, you will bind it on the fly. But as a static language, you can't say that. We don't know the type we don't know about the nav prop called manager. We don't know its type. We can't bind the remaining of the expression. In particular, we can't guarantee that the semantics are in the intended semantics, in that you can have two subtypes, both having the manager property that mean different things. So if you are of a type mindset, then you have to know the type.
There's already a type constraint in previous versions.
Yes, so the point is there's a type constraint in previous.
If that was your concern, why wouldn't you just use a loosely typed expression with the additional type constraint?
So the question is, we had a type constraint before. Why don't we combine the two?
Yeah, I mean, so if you ask for a feed of contacts, the feed's going to emit, regular contacts and employees. The server knows, right? So if you ask the server for, contact where manager equals, Andy, it's going to know. Right? So from a weekly type standpoint, there's no problem with that. I think the answer I remember in the discussion was the reason we did this is so we didn't have to execute multiple queries. Well, that presumes an implementation, right?
Yeah.
But if I understand correctly, that was the reason for it. But it actually, I think, complicates the query string quite a bit to have to strongly type your requests.
Mm-hmm. So the question is, why not just use the type constraint we already had? And and then the comment there, which is very important, is it implementation driven? We fail from time to time, but we try hard not to let implementation permeate the protocol a lot. I mean, specific implementations. We do make decisions based on the complexity based on the intrinsic complexity. Like, sometimes it's just for everybody it's very difficult. This one is not the case. Yeah, I agree. Sometimes we kind of have a glitch here or there, but we try not to do that. So coming back to this, there's two challenges with that, and maybe I'm too far on the typed side of things, but the primary challenge is that when you have a type constraint, first you have to look at the type constraint first and say, oh, well, given that this part of the predicate involves a type constraint, then maybe I'm safe here. And you can only do that if the thing is set up right. For example, here, if I have that expression and then it says and then a type constraint, then that works. But if it says or, for example, it doesn't work.
That's exactly how a link expression would work against SQL. You would write a type constraint in the expression to get only the ones of the type you expected.
Well, actually, no. Link is a good example. That's not how link would work, right? So in link, well, you can write it in two ways in link. One is you can write it by having an is check, and then cast whenever you have to access a specific property of the subtype. So you have to have a cast on every reference to a property of a subtype, or you would do an off type. And the off type has both the purpose of filtering the collection to the right subset that satisfies the type criteria, but also it changes the type of the implicit iteration variable so that further references to the iteration variable are of the right type. And this is exactly the problem. It's the same problem here. It's, as long as you don't change the type of the iteration variable, you have to keep checking on every part of the expression. So you have to have like a cast or something. And this is not implementation. I mean, syntactically, you have to kind of keep checking at every spot to make sure you indicate the type you meant to indicate there.
Is there anything stopping us from publishing employees as a top-level collection as well as contacts?
No, that's certainly an
alternative. That solves
alternative.
this problem with the, not having to specify, class, having that extra type of thing. If employees is a top-level thing, you can have it as well as contacts.
Yeah. So the point here is, well, why can't you just have employee as top level as well? You certainly can, and it does solve this problem. The only thing is sometimes people. This is kind of giving freedom to people to model different ways. Sometimes you truly want to treat everybody as a contact in some scenarios, but then you have some scenario where you will treat some subset special, but you don't want to lose the ability to, like, say you have a single listing of all the contacts.
Yeah.
That makes sense. So, like, to get back to your question by example, like, so one way to think about this is to say, actually, if I want to access the manager, and I don't want to talk about the employees, then what I would do is I can say, I can add the type to the path. And kind of using the link example, this is precisely the same as the off type operator in link. That what it does is it does two things in one. One is it says only give me the subset of that collection that it satisfies this type constraint. In this case, it's an employee, not all the contacts. And in doing that, since now I'm statically guaranteed to have only employees show up in this collection, then whenever I formulate a predicate, I can formulate the predicate in terms of the manager or the employee type. And now there's no casts or anything anywhere. Yes?
Why is it in the hierarchy part of the UI and not in the query part?
Excellent. The question is, why is it in the hierarchy part and not in the URI part?
In the query part.
In the query part. You can have it in the query part too. The semantics are slightly different though. Like the whole thing is, there's only one rule that describes the whole thing, and you get to choose where to put it. What this does is you're changing the type when this is a cast operator, right? If you do it in the path, you're actually scoping the path from the get-go. So now, from now on, everything is a subset, and it's properly typed. Now, sometimes you may not want to do that. Like, for example, you could say, I want everybody whose manager is Andy, or whose whose last name is Conrad, which is actually the manager's whole thing. So in that case, you can't do it here because it would exclude the contacts from the get-go. But you want to talk about the manager property in the predicate. So by putting it on the other side, even though the semantics of the actual operator are identical, the semantics of the entire question change, because now you can say where the manager is something or, and now you're back to the contact, and then you can say something else. Does that make any sense? No?
Maybe I've not completely understood now the difference.
So
What's the semantics of the second one?
let me see if I can switch. Do I make your guys' life really difficult if I switch computers? Guys in the back. I'm trying to switch to my laptop so I can project something. Let's see if this works.
The very first. Yeah. So you got to put employee in. You could do employee/manager.
Let's see if I can project. I have a little example then, because this is hard to. Whoa.
Did you hit source 2, Pablo?
Oh, I think I hit.
I screwed it all up.
So I did mess up with the whole deal. Excellent.
No, you get all the fields.
I'll switch back in just a sec if you want to.
You get all the inherited. Yeah, all the drive fields. Yeah. What he's doing is if he subclasses it, the namespace employee, then you only get the employee records. So in our case, you have the inheritance tree, you narrow yourself down to one path.
It's all right. You can switch back otherwise, because I was going to just take a minute. I can do it later. Let's switch back to the volume. Sorry.
More operations.
Sorry about that.
Everybody needs like.
All right. Let me.
People don't have a manager, you still get them.
So we can do this on the computer later. Let me walk through it though. So when you just say contacts, it's all the contacts. So this, whenever it doesn't matter where you put it, before, after, in an order by, anywhere. Whenever a type name shows up, the rule is that you do two things to whatever you're applying it to. You are forcing the type of the resulting expression to be of the new type, and you're effectively excluding the value if it is not type compatible. So excluding the value, of course, means different things in context. Like in the context of the collection, excluding the value means you'll eliminate it from the collection. So if you had two contacts, but only one of them was an employee, the collection has /employee on it, has one contact in it. If you're in the context of a predicate, then the value is already there, and you may have also an OR afterwards. So you can't really remove the value if you just address contacts, because the value is really there. It will be incorrect to kind of make it disappear. But what happens is, since it is type incompatible, we'll just null propagate out. So the cast results in a null expression that it just propagates out as null until it hits the kind of a binary operator edge, like an AND or an OR clause. So with that in mind, So the first one is all employees, so manager binds to the manager variable. And the second one is all contacts. So the first part of the predicate says, well, convert it to an employee, and that may or may not be null. Right? If it is not null, then access the manager property, and then the first name property, and then access that. If this instance wasn't an employee, then the cast will be null, which will null propagate outwards until the whole expression is null. And if the top level expression is null, the predicate is false, which would make the instance not satisfied, unless you had, say, an or and some other expression that didn't need it to be an employee. And in that case, maybe the second part of the or makes the expression true. Did that help? If not, this is much easier to explain with a working system than in abstract. But maybe it helped that we can do more on the laptop later. Okay, so let me do one or two more examples and see if this helps a little. So the employee kind of the type works everywhere, as I was saying before. So before I used in the path and I used it in the filter expression, but you can use it anywhere where you can refer to some member because the members may be in a subtype. So for example, let's say I want to have contacts and I want to expand the manager. Of course, manager only makes sense again in the context of an employee. So what this says is, get me all the contacts, and then again access the manager property if it is an employee. So if it is not an employee, that's going to be null anyway. So null propagation again will work outwards, and the property will be empty. So you won't even get the actual property because it doesn't exist in the type. But if you have it, then you will get the manager. So this works kind of across the board. Where it works on all the operators, so to speak. And I was using expand as a proxy to show something really different from the filter. So with this addition, this allows us to model one missing bit that we had before, which was we couldn't before allow navigation properties in subtypes in a hierarchy because we didn't have a way of using them. So this primitive allows us to basically let you model, basically use any of these inheritance constructs in the model, and the query algebra walks with it. So as you add stuff to your model, you will have ways of asking questions about that model. That some reasonable questions about inheritance? Okay. So the other topic around modeling. So these are all things that are modeling in the sense that they allow you to describe your data, like collections or inheritance. This one in particular has to do more with the nature of the information you expose, and geospatial information has been one of these topics where it has been tricky not to have it built in. We always try first to say, well, let's not build into the protocol. Let's have it, let's have people create patterns on top, and then we see which ones of those are really, tough to do that way. And this is an example of this. So things that we think we can manage. So the other thing with geospatial is it's a very broad topic, so it's easy to overdo it. So I'll give you examples of things we think we will do and things that we will not do. So there are things like contacts that live within 1 mile of my current position. That's the kind of question you would ask on a phone app. You have an application, works on your phone, you have a GPS, and you want to ask a simple question like, contacts or coffee shops or whatever within 1 mile. So this is a distance question, pretty reasonable. Contacts that live within the viewport. So this is an intersection question. I have an area and I have a bunch of points, and I want to see which of those points intersect or fall inside my area. That seems pretty reasonable too. Give me all the coffee shops that I can see in my current screen on my phone. But then, if you get deep into this topic, the domain of geospatial information is very specialized and it's very broad. So people in more advanced, stacks are able to ask questions like, I'm sitting in this spot. I'm putting an antenna that maybe is a, microwave antenna or something on that spot. Do I have line of sight? That's a very difficult question. We're not trying to answer questions like that. Those are, you need to know the topology of the player. Those are difficult stuff. Once you have a problem like that, this is not your protocol. You want a special thing. But the first two are the kind of things you would expect a modern phone app or tablet app to do. So we have to handle a couple of things there. We have to represent geospatial data on the wire and on questions, and we have to have ways of asking questions about these things. So the way we ask questions is you start to see these dots in places. Even though this is part of the protocol, this is how we expect to enable extensibility of the protocol. These are functions. And the prefix, you can invent your own prefixes. We took geo because we thought it was important enough. But you get to pick your own if you want for other functionalities. So for example, if our contact property type before had a home location property, you can say, well, give me the distance between the home location and my current location, which you arguably get from the GPS or something, and it's that point literal there, and saying if it is less than something, then that must match the criteria. And the second one is an intersection query that says, if I have my home location and then I have a polygon literal that represents a viewport in the map in my phone, then I can check if the intersection is true or not. The one interesting thing of doing it like this is, this one is tricky because the radius is like a circle, but you could, if you don't mind having a rectangle kind of match, you could say greater than, less than, and all that. But the problem is that loses the intent of the question to the point that makes it tricky to index the thing. If you have a backend that can do this fast. These questions capture the intent very precisely. So when you execute them in whatever your implementation is, you can choose to brute force it, or you can choose to have some backend that does some geospatial magic and then answers the question fast. And we've seen both instances already in experiments, and both seem to fit very well in the model. So from the representation perspective, on metadata, this is a typical type declaration in dollar metadata. And you can see the home location property is declared as a geography point. The way we exposed geospatial information is there are two hierarchies. There is a geography hierarchy and a geometry hierarchy. That depends on whether you want to think about the world flat or rounded. And there's a lot of work in geospatial that actually assumes a flat Earth. So you kind of have to have both. You have to indicate what is the coordinate system or have it on every instance. And then you can say it is a generic construct, like say it's a geography construct, or it can be more specific and say this is a point or a polygon or a multi-line or something like that. At the instance level, this is a space that is broad. We're not experts, and there's a lot of existing work, so we didn't want to invent representations for this stuff. So for the case of the atom representation, there is already something in GML for representing geospatial information in XML. So which is we are using that. So this is an instance of the point that represents where we are sitting right now. Yes.
So Pablo, again, I'll ask you the philosophy question.
Yeah.
There are 100 specific things that you could have added.
Yeah.
Right. You could have added your social graph to be expressed much more easily. For example, in OData, you can kind of query your friends and your followers and all that stuff. And the scope of things that you could add, right, is very large. Why did you pick this?
So let me answer in general and then in the specific. In general, I think that we have to watch how much we add, but also we have to watch how we add it. Most of the features that I've talked so far are pay-for-play features. Like most people that don't care about geospatial information will never have to know, parse, or deal with geospatial information. So, like, I always have the curl test. Curl is this command line HTTP tool. And if I can't use an OData API, a simple OData API with curl, then there is something wrong. This one I can't, quickly I can't because I never remember the namespace and, things like this happen. But that is reasonable. Like what that says is the API scales down very naturally, but it gives you space to be fancy. So that is a kind of a design principle, if you will, and so far it has been working pretty well. On the specifics, we found, and this is kind of a pattern overall, we found that geospatial information is tricky to model on top of the system because there are questions like distance questions that are very hard to ask if you have to decompose the question. In fact, it shifts the complexity to the user of the API because now, in the simplest case, you have to ask a bounding box question. And then you have funky effects like, well, it's outside of the circle but inside of the bounding box, and then it acts as the implementer because now they have to run queries that are, it could be substantially worse than domain-specific query. So I get the sense, and this is obviously open for debate, but I get the sense that this is the ones that pays off, and actually taxes a few, which are the ones implementing the frameworks that support OData, but it benefits and removes complexity from almost everybody else.
But I could make the same claim about friends and friends followers and friends followers, right? So graph traversal on a friend list is going to be very difficult to express in query, and probably therefore the kind of the structure that you write. So the same kind of argument can be made for many other queries also, right?
Absolutely. So the point is, you can make the same argument about a ton of other queries. Absolutely. And the question is, how far do we take it? And I think that's the fine line that we as a community have to walk. Is this thing that people are asking about enough that it's going to make everybody's life better, or are we going to help one or two folks and then carry this tax on everybody else? Absolutely.
I would ask, why create a data type called a point when we've been using lat long and floating point since V1, I think, or V2 works just fine. It seems like the only reason you would do that is so that you can formulate the query. It's not about the data. Data doesn't need a new data type to store lat long. You can use it.
So the question is
values or a structure value, but.
Yeah. So the question is, why have a data type instead of just lat long? And that has worked well in the past. Yeah, it works well for lat long.
Or anything else.
Well, if you have to have, say, for example, the viewport question, the viewport example I was using before, you have to define a polygon.
But do you need it to store it? I don't think you need to define a polygon generically for everybody so that you can store a polygon. I could easily store a polygon in OData v2. So my question is this really all about the query string? So you can define an object called a point or a polygon on the query string so you can ask the question. Right? You're taking kind of what's getting to be more and more driving what would otherwise be a function into the query string, so making the query string very functional.
Yeah. That's a very good question. The majority, I think this is the observation you're making. Like pretty much all the examples I had here are about the thing stored are points, and the polygons are used for questions. There are other scenarios where polygons are actually stored. The question is, do they hold water? Like, is it enough? Is there enough of them to introduce this, or should we just dial it down? And
why not define something's much more common, street address? Define a well-known street address structure and let everybody use it, right? Why not do that? Because you don't need to. That would be the answer, right?
Yeah.
And my answer would be, well, you don't need to here either.
Well,
yeah, that's a great point.
Seem to, unless you're trying to define it on a one-line query string, you need an object called a point, which you can then kind of semantically compare to this object called a point that's in storage.
Yeah, we're going to get through a few more slides, and Arlo, who actually worked on this feature, has a comment. But we should do, tomorrow we have a lot of time for kind of open space. Maybe everybody interested in, I'm really curious about this one. So maybe everybody that's interested in geospatial information, we should do a little get together tomorrow and drill into this topic in particular. Because I think
I just want to give a +1 for the geospatial because we wrote it in version 2, and it was a real pain. And the queries that we can't express any queries without making a service operation for every custom query. And the whole purpose of OData was to enable the end user to have the ability to get data or express a query without having to write a custom SOAP API for every single one. Without the ability to represent polygons and lines and other shapes, they can't. And it's very difficult to update and do that. And we actually have an example we're going to show later. And how difficult it was for version 2. So I'm +1 on this. I think Mike is +1
Okay.
too.
So it's good to hear. I think that's exactly kind of the debate I wanted to have, where there is this of course we want the simplest thing that we'll do, but we want. I mean, if we go farther than that, then we have these problems. So this is the kind of thing we have to all sit down together, exchange scenarios, and see. Well, do they hold water? Is it enough to make it into a protocol or not? I have my own opinion, but that's by no means, that says that it. I mean, I'm not an expert in this area, so I'd be curious to hear what you guys.
I'm not an
have.
expert on it either, but I had to write it, and I appreciate that it's going in.
That's a good way of thinking about it. Arlo, do you have something to say?
Yeah, I just wanted to make a comment that geospatial is one of those things that starts out easy until you find out it's imprecise, and then it starts getting very complicated very quickly. Like, no one actually wants to know all the coffee shops that are within a mile. They want to know that are within a mile by drive distance. And drive distance can't be represented using distance. You have to know line strings that represent every street around in order to do that. And suddenly you need to store a lot more than points. Or they want to know all the things that are in my zip code, not that are within 2 miles of me. Well, zip codes are big, ugly polygons with all sorts of funny corners, and some of them have holes in the middle. And so it starts getting very, very complicated very, very quickly. And that's why the geospatial community has gone off and developed all of these standards. You know, originally they started with just floats and so on, but even for fairly normal sorts of applications, you end up getting some very complicated data pretty quickly.
Okay. So that was the XML representation. This is a GeoJSON representation. Again, trying not to invent stuff. This is GeoJSON. Some people are already working on GeoJSON. We just took it. So this is pretty industry standard. This most folks are using when they have to represent geospatial information. So I'm running a little over, but I want to keep. Like, I really like the debate in this format. Do you folks care if I go over a little?
I'm okay.
Okay, so I'll go over a little. I'm sure somebody organizing this thing is going to be less happy about it, but we'll push them in that direction. So the next thing I want to talk about, and I'll try to make this one brief because it's known to never finish. So I'll just make a statement, and then if we want to discuss this one, let's just take it to one of the sessions tomorrow. So I worked at Microsoft 10 years. I think every year we've had an attempt at supporting containment somewhere, like in SQL, in WinFS, in object spaces or something, in entity framework, and the problem is not that it's particularly difficult in any one instance. The problem is nobody agrees what containment means. And it's surprisingly tricky, even though you say containment and the other guy says, yeah, containment, let's do it. And then you go do it, and it turns out that nobody agrees with what you have to go do. There's problems like, what is the reachability contract of containment? Do you have to go through a parent, or can you go inside, or the lifetime? If you kill the parent, do you have to erase the children? And if you do, then what's up with the reachability you said before? And what's a set that contains them? Can you recurse? Can you have a contained thing that contains other things? And what does it mean for inheritance? If you have something contains something else, but then inherit from it, can you contain them? And do you contain them of the same kind? Like this, it gets crazy. And this is we don't want to have to explain any of this. We want to have a simple statement that says sometimes you contain things, sometimes you don't. And maybe there is no answer for this, but this is how we struggle with this particular problem.
So, question?
Yeah.
So I mentioned OCL earlier, but
yeah.
I forgot to tie it. It's a companion standard to UML.
Okay.
UML provides pretty clear and precise definition for containment.
Mm-hmm.
You guys reference UML?
We haven't before used UML for other things. So, many of us know UML. I'm not sure it covers. Let me drill on it, and then we can get back to it. Like, I'm not sure it covers the level of narrowness we want to go for here. But I'd be curious to drill on this. So the simple form of containment we wanted to have was to just quote unquote say, you have a sales order. Why do you have the sales order line set? Nobody wants it. It's at the top level. It's really weird. Nobody wants the lines collection because you don't want them to query without the orders unless you're doing some analytics or something. So why do you have it? Let's just have an option that says don't want to have it, and that's it. So that seems to be the general desire of most people, not just to avoid having top-level tables that are an artifact of the modeling language rather than a requirement of the service. So you can do something like this, and this is a one-to-many thing, so these things live within the lifetime of that guy. But then you have recursion as well, where you have something like folders, and you have to go and recurse on it. So the way we were thinking about this, and again, I'm going to just touch on it briefly now, and if folks are interested about containment, I would love to have a specific discussion about it. But we said, well, the least we can do is we can take the navigation property of the parent and say, this is a container. So this contains the target. What that says is now the other side doesn't need a top-level entity set anymore. So now the only way to reach the children is through the parent. Everything else holds. So the keys need to be unique within the parent because you cannot reach them outside of the parent, at least for all you see in the addressing scheme. And since you killed the top-level set, then you have to reach these things through a nav prop that you just created or some other nav prop that lands you on the object. And when you create something, you have to create it through the parent. So if you, like, the interesting thing about this approach is that if you forget all this modeling stuff, you can say, look, to reach a children, you take the URL of the parent and it's slash something, and kind of the hierarchy of URLs represents the hierarchy of the objects for real. Then this gets a reasonable effect. It makes a lot of trade-offs, but it makes a reasonable effect there. So this is how we're thinking about containment, but I'm sure we're going to have a debate about this, so I'm going to leave it at that. Unless someone is really passionate about some particular statement. Okay, then move on so I don't go over for too much. So a few other things I'll just mention quickly. We did patch, we had merge. It was, since we came up with merge, patch became a standard, so we're adopting it. We tweaked our versioning scheme to allow clients to not have to implement all the way back to V1. If you want to say, look, actually, there's some glitches in V1 I don't want to deal with. I want to start with V3, then you can do that and still work with servers that are new and understand it. And we did name streams. A lot of people had multiple media items associated with entities, and you wanted to have more than one and have names. Like the usual is multiple resolution pictures or multiple resolution video streams, where you want to say high res, low res, or things like that. And you don't want to have multiple entities. They pollute your model, and all you really wanted was a link with a name. So this allows you to do that. All right. So two things we touched on efficiency in this round of the protocol. One is this preference header, where the problem we had is in a typical OData v2, if a client sends a post to a collection on the server and says, I want to create a new contact, and it sends some payload, the server replies back and says, OK, I created it, and by the way, here's the whole thing again. And there is reasons for this. Like sometimes the server changes things or completes the picture or computes values. So oftentimes you do want the value back in addition to the location, except when the thing is really big and you didn't want it. And the opposite thing happens on put. On put, typical OData servers today, you say put something, and they come back with 204, no content. Sometimes the server did recompute something, and you wanted the content, but OData won't give it to you. So it turns out that HTTP folks were already working on a proposal to address this, so we took that. So now when you post something, or put it, or patch it for that matter, you can state your preference. And this is a hint. The server can choose to ignore it. But you can state your preference and say, for example, no content. And if you say no content, and the server knows about this header, then it'll say preference applied, no content. And it'll actually return no content. You can do the opposite as well. You can say patch and say return content. And the server, if it understood what you said, it'll say a preference applied, return content, and actually include the payload. And this was very handy because the HTTP folks were already working on it, so we didn't have to kind of create the actual mechanics of it. We just used it for this. It was common enough that it would save bandwidth. It gives you some perf back. So we thought it was handy. So the other one, which I'll cover briefly, but yeah.
It's just all or nothing then?
Yeah.
Okay, you can't get the one ID field back out of that page.
You can't. Like you open the door and then it goes like, So the location header is what you get. You have to get the location header and retrieve the entity. So I'll touch briefly on this so I don't go over by too much. And I think this is another topic that for folks interested, I would love to have some spend 45 minutes or so tomorrow talking about it. So format efficiency. How do we, our atom payload is big. I think anybody that looked at the thing agrees with that. So how do we address it? We thought everywhere from tweak the atom payload to go to JSON, to go to fancy JSON, to go to really fancy JSON, to let's do some crazy binary thing that nobody understands. And then we took some measurements, and it turns out that after a certain point, the benefits are not that big, and the thing gets very obscure. So the question is, how do we keep it really simple, but still get some efficiency back? So this is the JSON data, a JSON instance today. If you look at here, JSON is about between a half and a third of the size of the corresponding atom payload. So it seems like a better starting point. We also looked at binary, but binary, you get back to it later. Short story is, nobody can read it. You have to have libraries everywhere. Like JSON is everywhere. Like it seems too much of a complexity tax to impose binary on everybody. So this is a V2 response. About half of an average response like this is made of URLs and type names. So no data, just URLs and type names, and half is your data. So the question is, what can we do here so that we remove all the control information and still make it semantically equivalent? So no loss of functionality, just less stuff on the wire. So if you remove all the control information, you get what you see over there on the left, which not only is a lot smaller, which is a feature, but also it looks like what it looked like if this was your own custom API. So you get the goodness of OData, tools, and metadata, and all that stuff. But if you don't care about any of this and you're just using jQuery for a quick web page that displays the thing, you don't need to think about any of it. It's just a JSON object. So it's kind of best of both as long as we can sustain this level of cleanliness. And it remains to be seen if we can sustain it. But
I like the new date format.
Nice.
The V-date's killing us.
So the comment was, I like the new date format. We have this talk at the end called the good, the bad, and the ugly. We'll have a good conversation about the date format.
A JSON date format that can't be serialized using JSON libraries.
Yeah,
that's pretty good.
That's a good example of it. So this is just a zoom in on that. This is what the thing looks like. So a lot cleaner. Obviously, you can't just do this and move on because we lost a lot of information that, it's bloated, but we're not that dumb. Like we need it for something. So we need to get this functionality back. And the way we're doing that is the approach that we took is we said, first of all, what we're going to make a few key assumptions. The most important assumption of all is either your client is very simple and you don't care about any of this stuff. You don't want to hear the word OData. This is just some URL you get from the thing, you get some JSON, put it in the UI, you're done. No modeling, discussion, none of this. The other case is if you know about metadata, then you really know about metadata. You know all of it. So you pull the metadata document, fully interpret the thing. No in-betweens. Like once you make this assumption, then you can make interesting decisions, afterwards. The other one is no ambiguity. VTech and Jason are sitting there. VTech and Clemens are sitting there parsing JSON. And these guys have these crazy questions all the time about how the heck do we parse this? We don't know what it is. So we want no ambiguity on the payloads. And then no out-of-band knowledge. This is a good kind of REST decoupling principle where you don't want clients to know about to be required to know about servers model out-of-band. You want them in-band. And clients that don't care can ignore the information. And finally, which is the last two, just don't do weird stuff. Keep the thing so that if you don't care about all this OData gunk, the thing looks like a regular JSON object that a regular person would put together. And if you care, you look a little deeper into it and you find the extra stuff that makes the thing fancier. So this is what a payload looks like in a more expanded case where you see things like, complex properties look like complex properties. You just have two properties inside, so it's pretty reasonable. Arrays look like an array. Like that's a new innovation which is created where an array looks like an array. It's a JSON array. You don't need to know anything about it. And whenever we have to say something that is weird, because you always keep some weirdness, we use the annotation syntax is wrong. Sorry about that, but we use annotations, and I'll talk about annotations in a minute. But the way to think about this is if we really, really need to say something, we say it in a way that is clearly not your data. So you can distinguish the two mechanically if you don't care about it. And lastly, the way we capture this information, sorry, I missed a build-up here. So the way we capture the information that is missing here is we move it to templates, which should have been somewhere. Anyway, I'll find the slide later. So the way we capture this is we move these as templates to metadata so you can recompute them back from metadata. So for example, if you need to know the edit link, you can have a little expression that says the edit link is /contacts, and then take the ID, put it in parentheses, or put it after a slash, and that's your new URL. So clients that don't care, and clients that care and have metadata can interpret that expression and can put the URL together. So we didn't really lose any functionality. We just made it that by default, this stuff is regular enough that we can express it as patterns in metadata and not have it in data everywhere. So this saves, on both ends a lot of space, and it simplifies the payload a lot. So if folks are interested, I'd be happy to discuss this further later. So finally, to wrap up on extensibility, I'm not going to get into this. The next 2 talks are going to discuss extensibility. Extensibility has a number of fronts. One is around metadata, where we allow you to say your own things about the system in addition to the things we say about the system, and do it in a way that is unambiguous. It allows for sharing of these concepts across independent systems, and in a way that is pretty expressive. Like sometimes you just want to say a name, but sometimes you want to say something fancy, like you want to make a statement that is a function of the entities. Like for example, the efficient format expressions that we were talking about before. So we want to enable that. There's data extensibility as well, where you want to say things about the instances rather than about the whole thing. And then finally, you need extensibility on how you interact with these systems. How can you add a little something in the URL without breaking everybody else, like geo.distance? What if you had your own, foo.bar, where you can add it so people don't have to do complicated things, but still everything works. You're not disrupting the system. And similarly, well, we have get, post, put, patch, all that, and that's a uniform interface. It's great, but what makes it great is that the meaning is fixed, which also means you can't change the meaning. So what if you need to have a custom thing going on, like something that means something special, like say an action that you post to and doesn't just create something, it kicks some process off or something. We want to enable people to model that, and actions are going to do that. And Alex is going to talk about actions next. So I left a summary here for folks when you go through a deck later, and if you want to see all the things we touched on. I know we covered quite a bit of surface. I wanted to kind of put all these bits of information in your head, so in the rest of today and tomorrow, you can bring topics up that you want to discuss. You can queue up topics for the open kind of discussion tomorrow, and have the opportunity to see what you're seeing here and bring up anything you want to discuss about. And with that, I'm going to hand it over to the next speaker to do actions, I think.
Take a 10-minute break.